All right, guys, welcome back to another KevCAM night class tonight. Tonight, have Andrew helping out with any questions or concerns that come up along the way for you guys. And then also have Greg Payton kind of give you guys a little update from SolidWorks world. But I'm looking through the list of everybody that's in here, and I see everybody that's been in here before, so I'm not going to go through the whole rigmarole of the go-to meeting. But kind of leaning more on the SolidWorks world side of things, which was last week. For those of you guys who don't know, we did add 2 new videos up here. This is with our, I'm having a brain fart. What's the name of that machine, Greg?
That's the Defiance.
Defiance, little tabletop machine. And I wanted to get a good picture of, we got Sydney right here for those of you guys that don't know, and then Ken right here. And these are 2 different cuts. And Greg, do you want to kind of explain what we're kind of cutting on that little tiny benchtop?
Yeah. So what we wanted to do was we wanted to take this little benchtop mill out to the show. 1, because it's portable, easy to get that mill in and out of places. And 2, to highlight the power of our iMachining module. What I like about these videos is that it really showcases our small tool protection during its cuts. So you can see that even though we're traveling at a high rate of speed, we're actually cutting in these videos 1018 cold rolled stainless, or I'm sorry, cold rolled steel.
That's inside
Andrew got on that one. Yeah. Cold rolled steel, and with a 3/16 end mill going 3/8 depth of cut. And what it shows is that high rate of speed can be applied to these smaller tools and still keep that tool from overloading in corners. So yeah, if you guys get a chance to check it out on the SolidCAM University YouTube site.
Yeah, I think like Ben already checked it out, so you're ahead of the curve. Ben.
Yeah,
nice.
Yeah, he is. And
it was really cool to have this thing run. What we would do is whenever sessions would end and folks would come in for like to get their meals and everything, we would just fire this puppy up and let it go to work on the 1018, and it was pretty awesome. People, they start to listen to it, they'd see we've got monitors on top of that little machine, and they'd start to shake. And really kind of watching a video is cool, but man, seeing it in person is it's pretty impressive. So it was fun. It was fun to get talking with folks who, could see that and then say, oh my gosh, this is something special, when they've been around other machines trying to do the same thing, but much, much slower on softer material. So they always would take a double take. 1018? Really? it was fun to kind of brag about it.
And I think the best part,
we had other CAM systems out there with large machines at the show. That were cutting about half as fast as that little machine was in iMachining.
In aluminum, right? They were cutting the same part in aluminum, and it was quite a bit slower. And yeah, so it was kind of cool to brag about it.
Sweet. So yeah, if you guys want to check that out, come over to the SolidCAM University channel, and as soon as I can find what I did with it here. Oh, I must have closed it. Let's go to YouTube and go to the KevCAM as soon as I can get there. And there we go.
I got to give a shout out to all the international resellers of SolidCAM. They said they use the KevCAM videos quite a bit, and that we take way too long to get through to the important stuff. So this one's for you guys. As you're fast forwarding through this. Yes. Sorry about it, but we're just sharing everything. But anyways, thanks for tuning in and fast forwarding through our part. I kid.
So I guess we better get the ball rolling here.
Yeah, I guess that was the music to get it rolling, I guess. Yeah.
Okay, so tonight we are covering simultaneous tilted turning. So this takes into factor basically turning and simultaneous 5-axis all in one. So with this operation, it enables you to perform machining of curved shaped tool paths using tilted capabilities of tools with the round insert. So the tool, you can define it by tilt lines. You can tell it to stay tangent to that surface, so it's like I said, we're kind of combining two different systems here all in one to get this tilted simultaneous turning path here. So let's go ahead and grab our geometry here. And we'll start here, and we'll kind of end right here. Hit our green checkbox. This is going to look the same as normal. Now, when we get over to our tool here, grab tool number 8. Now, a lot of times, your tool mounting on this particular one, get one that's pretty close. It doesn't have to be. We can go, you know, in the Z-axis, or we can go in the X-axis for this one, because we're basically telling it how to tilt more than anything. So levels are pretty close to the same. With the levels, though, you do have a couple different options right here, and to more customize it, and they're more pulling this out of the 5-axis portion of it. So I'm trying to find, I did have some little note here. I'm just trying to find it real quick. So keeping this initial orientation until distance is basically, if you hit this checkbox, you guys can specify a distance that it can rapid as the head is rotating. So you guys can actually, you know, we have a clearance plane of 10 millimeters right here, but if you want it to rotate below that, we can set that up, and we can put in there the distance and the angle steps for the rapid moves right here for you guys. So just some more customization, and this is just clearance only of what's kind of going on right here. Now in the technology, are we wanting to cut, since we're using a button cutter or a round insert, are we, cutting on the right side of the cutter, or are we cutting on the left side? So for this particular cut right here, we'll be coming in here and using the, we'll be cutting side of right. So we'll come in here and just dish this material out of here. Now to me, I'd say that would be left, but let me just try it real quick here. So we'll be coming in here and just dishing this area out. So let's go to tool axis control. So if you do not tilted, it's just going to stay normal to that surface. So as it's going through the surface, it's going to stay right normal to that, which is going to definitely cause us some issues here. Just because as you can see, as we're coming in here, that tool is not going to be able to fit in there in the angle itself. So we just do a save and calculate real quick. Kind of show you what it's going to look like without using our tilt lines. Can I get zoomed in there for you? So it starts off good. And now, since we're trying to stay tangent to that surface, we're starting to hit a little bit of material, and it's going to get a pretty large crash going on right here because it's staying normal to that surface. So not good. So that's why we can add our tilt lines in there. So in the certain scenarios, you guys can use the not to be tilted. It all depends on the geometry that you're cutting. But for this particular one, to get our tooling in there, we want to use our tilt lines. Now, what I'm going to do is, I do have a couple tilt lines drawn in here, so I'll grab these real quick. And you always want to make sure those arrows are pointed in the right direction. Flip that one around. Okay, so all my arrows are going up. Is perfect. Now we have 3 different options down here. We have all lines weighted by distance. We have always use the closest 2 lines, and always closest to surface. So the all lines by weighted by distance is, it's going to take all those lines and average them out. So as we're kind of coming in here, zoom back in here, what it's going to do is it's going to come in straight in here, and it's going to slowly flow over. And for those of you guys that didn't, or a little bit of repeat for those of you guys that did watch the simultaneous 5-axis with tilt lines, but doing the exact same thing. So it's going to grab this line and average them out. And so it's going to start straight up and down, slowly rotate the head to this line right here. And then as it transitions over, it's going to slowly rotate to this line over here, and then keep moving forward, following the average through these lines. So it's going to, between each line, it's going to be rotating to achieve this straight up and down. So now if you use by 2 lines, the direction of the tool is approximated between 2 consecutive tilt lines. So if you guys just had 2 lines only, let's say just, this one and this one, it's going to take that cut and to just flow it through just based off of those 2 lines only for you guys. So, and then always closest to surface allows you to tilt the tool as defined in the tilt lines section. This is maintained by the tilt lines that are closest to the distance of the surface. That one don't use very much. More or less, your two go-to ones are going to be the 2 lines, or let's say the average of these right here. So let's take a peek and do a save and calculate here. And let's go and simulate this. Do a turning. So we're coming in straight with that tilt line. It's going to start rotating. Gets a little close to the shank there, and now we're tilting out. So that's the benefits of having those tilt lines in there. So we're kind of coming in there and just following those lines all the way through. And these can just be regular sketch lines that you've drawn in there. You guys can have these tilt however which way you guys want to get that tooling in there as tight as possible for you guys. Now, kind of continuing on here, you guys can set up angle ranges just exactly like what we did with the simultaneous 4 and 5 axis. So we can tell it to stay between certain degrees in here. So, even though, well, more for the kind of the tight areas to keep, let's say you want to stay between 40 and 50 degrees because that's your clearance area that you guys have. So that option is there for you guys to add that in there.
Kevin, looks like we got a question in there from Ben. Can you get more clearance by tilting the second to last arrow out more?
Yes. Yep, absolutely. And the reason I didn't do this one is because I want you guys to be able to have this part. And for those of you guys that would like this part, all of you guys that have SolidCAM have this part, and it's under the advanced mill turn part. So that way you guys can kind of go in there and take a peek and see exactly what's going on in there for that. Now, granted, there's going to be a whole slew of operations down here because this is quite the mill turn part to get it all done, but I just kind of eliminated all that stuff. So, but yes, to answer your question, if I would have moved that line over, that would have kept that clearance away from that neck a little bit more for us. Good question. And let's see, advanced mill turn part called, oh, it's just called advanced mill turn part. So if you guys go to your, let me just open up my computer here, go to C, users, public documents, SolidCAM 17, users, getting started with examples, and SolidWorks. If you rate mill turn advanced, this one right here. So this is the one that would have this feature in it. And I think there's actually a couple of them in here. So perfect. Ben, do you want me to put the link in there for you, that path? Okay. So, so in here, so we got our tilt lines and all that good stuff here. Linking is more of your linking like you would see in 5-axis simultaneous. So you can do as a lead in or a lead out. You can change from your first entry, you can do, direct distance, use safety distance. So this is more pulling from the 5-axis portion than the turning portion of the mill turn right here. And then your default lead in, lead out is just based off of this right here. So if you guys use a lead in, lead out, you can get to it by clicking this button right here, or you can get to it just by coming right here. And like I said, these are pretty much the exact same thing as what you guys are used to seeing in the simultaneous, or what I've covered in the simultaneous. So you can do vertical tangent arc, you can fix the tool orientation, or you can do a variable, or you can just do tilted. So a lot of options as you're kind of arcing in and arcing off. And so this is really where this comes in the big factor is trying to get into those tight areas, kind of like what you're talking about, Ben. So you can navigate that tool to get in there, to get those little shapes, to get that material out of there. We also have gouge check in here, so you can do gouge check against the surface, against the holder, set up as many gouges as you would like. So this is, like I said, more along the HSS and the 5-axis portion right here. And same thing with the clearance, even though that we're not running a cylinder here, but it's more pulling off of that 5-axis. So this is more of your clearance for holders and your arbor, all that good stuff. And then machine controls and miscellaneous parameters. So let's take a peek at, so we did that one without, I think we got everything here. Let's do save and calculate. And let's do solid verify here. So not a whole lot of simultaneous movement going on there, but that's pretty much the only way that you would be able to get in there, other than having to create a fully custom tool to get in there. So that's where the simulation or the simultaneous turning kind of comes into factor. Any questions, guys? I know it's another short class here, but kind of like what I said with the whole turning aspect of things, there's just not a whole lot in there for you guys, and they really simplified it for you guys. So don't see any questions coming through yet. You talked about indexing the part 2. Ben, you got me a little confused. Clearance planes. So let me get over to my levels here. And rotate the turret or the part. Oh, so when we're doing this, this is going to be the turret rotating, and this is going to be like your Integrex machines where you kind of got that 5-axis head on there. I think I showed that one last week with that Integrex where you can move the head. The spindle is going to be fixed for the most, well, especially for a simultaneous. Your spindle is not going to, or your chuck, I guess you could say, is not going to be moved. It's going to be your tooling moving around it. So, yep, perfect. Any other questions, guys? Greg, am I missing anything?
No, it's looking pretty good so far. Maybe you want to go over the types of machines that this type of toolpath would be used on.
Yeah,
so like your Mazak Integrexes or.
Yeah, this is going to be more for. Let's see. For those guys, let me pull up here. grab a decent picture here. Ben, this will kind of help you out too. So like this machine, of course, then gives me a little picture. So kind of like this right here. So you have your spindle or your chuck rotating around, and then you got kind of basically like a 5-axis head, or I guess a 4-axis head going right here. So this head would be, your spindle would be turning right here, and this head would be rotating in a fixed position. I should say the head would be rotating, but the spindle inside of that head will not be spinning. It will be locked in a fixed position with that tool insert going through the movements. So trying to think of any other, you got the Kumul.
Akuma has the Multus. Morisiki has their NTX series.
Morisiki, what was it? The NTS?
NTX, like an NTX 1000. Nancy, Tango, X-ray.
Yep. So here's another kind of example. You got this head that spins pretty much all the way around, can go all the way around. This one may not be able to go all the way around to the bottom side of the part here, but does that kind of give you kind of a clear picture? Let's see. Okay, can you cam turning like part like? Can you cam turn a part like this? Ben, I think I answered your question because you wrote okay, but I'm not sure. Make a cam. Oh, yeah, a cam like a camshaft. Correct? Like for a car? Yes. Yep. Absolutely. That's kind of what these machines can do for you. So yeah, with the lobes in there and everything, so that this head would be going up and down as your spindle is rotating right here. So, yep. Ben, you should go and buy one of these machines. No, these are a little bit on the pricier side, but there's so much more you can do with them. And we'll be really diving in to the, I think more or less the Integrex, just because I have a full machine sim that I can kind of show you guys on with the Integrex when we get into the mill turn. But yeah, kind of showing what that upper head and the lower turret can do for the mill turn. And for those of you guys, I know we got a lot of regulars in here. Is there a specific machine that you guys would like to see me use when I'm doing the mill turn kind of going forward? Index has 2B axis. No preference. Check out index. INDX. Oh, so Ronnie, is this one kind of same lines except the bottom does the rotation? Trying to get a good shot here. Oh, it looks like that one's set up different than this one. Yeah, that's exactly what we're looking at, though. Cool. No, I never even heard this brand before. But yeah, it looks pretty close to kind of the Integrex setup here. Just trying to find a better inside picture of this one. Clear. Huh. Yeah, neat. But doesn't matter. Okay, our company is looking into a DMG Mori. All right, so Matthew, what I'll try to do is I'll try to put together a Mori or get one of the posts from the post guys, that Mori, that TNX. I think Greg, one of the customers you were on site, isn't that what they have?
Not that exact machine, but we do have a couple other customers that do have the NTX 1000.
Okay.
And I have seen machine sims for that one.
Okay.
So it should be available for you.
So yeah, Matthew, we'll kind of get those. We'll do some. We're going to kind of go through, like I talked last week, and I feel like I'm rambling on here, but kind of moving up in stages for you guys to the mill turn. So we'll start off some real easy parts, and I would like to spend one night class if it's 20-minute long class or an hour-long class, but I want to kind of do this in steps for you guys, just because there's quite a bit, more or less. Setting up your coordinate system and tool mounting is kind of the biggest keys for the mill turn. So we'll start off with some really simplified parts for you guys, and then next one we'll go to a little bit harder part, and my end goal is when we're on our last mill turn part, we'll be programming this part for you guys on the fly. Lot going on here, and maybe not do the entire part, but this pretty much has everything that a mill turn machine could do. So, and Ben, you were talking about the lobes for a cam and stuff like that. That's exactly what we're kind of showing off right here, is the lobes going all the way around for you guys. So, but all right, guys. Well, I don't think I'm missing anything with the simultaneous. Like I said, pretty simple, easy. A little bit of mixture of turning, a little bit of mixture of simultaneous 5-axis or HSS in here for you guys. Pretty easy to use. So you got your basic control. You don't have to worry about all the different drop downs like you do with the simultaneous 5-axis, but you do get the tilt lines, which is definitely beneficial, especially in a case like this, because if we stayed normal up to that surface, we're going to be crashing our in there. So want one for Christmas? Yeah, you and me both, Rick. I'd love to have one sitting in the garage. But all right, guys. Well, if we don't have anything else, you guys all should have my email address. Matthew did hop in a little bit later. Matthew, do you have my email address? I do. Okay, perfect. So you guys, if you guys have questions, concerns, shoot me an email or give us a call on the support line. And yeah, we'll see you guys next week. And next week, I think we're starting the mill turn. Let me just double check. And go to webinars, night class. Yep. So we're getting started with mill turn. So we'll be covering that next week for you guys. So, all right, guys. Well, have a great, wonderful rest of your night. Thanks for attending the night class. Andrew, you got anything else to add? Andrew fell asleep.
I did fall asleep. Nope. Nothing of substance other than drive safe. I'm just kidding. I know everybody's at home, but yeah. Thanks for checking in, guys, and definitely pass us along. And anybody you want to buy SolidCAM in the Northeast, you let them know that I'll help them out, because that's my territory. So shameless pitch happening right there. But yeah. All right, that's all I got.
All right, guys. Well, have a wonderful night, and we will see you guys. Oh, wait, Ronnie threw something in here. Let me sent me a link here. Oh, okay. So this is the machine. Ronnie, is this the machine you're using? Or one of the ones that you're programming with? Yes, no. Possibly. Yeah, this is some cool stuff. You got the upper head and lower head. Always say click on the picture.
Ronnie, that link, Kevin really blindly trusts you like that. You could have sent anything. It would have been on the broadcast, and Kevin would have had to gone in and edit it out. So yeah. You're a gentleman and a scholar for sending something on topic. So well done.
Ronnie and I,
Kevin just blindly clicked on it.
Ronnie and I have a long working relationship. I can trust him.
I love it. Very cool. I'm just you run.
No, it's all good. No, it's it's definitely a cool machine. But yeah, I don't think Ronnie will have that machine in our arsenal just because I haven't heard of it. But we can definitely, as they come through, possibly add that in there. And when you buy that machine, Ronnie, we'll make that machine for you. So. All right, guys, have a great, wonderful rest of your night, and we will. If I don't talk to you in the meantime, we'll talk to you guys next week. All right, see you guys.